Our next function or type of function that we have is bijective, and that's a one-to-one correspondence. What does that mean is that functions are both one-to-one and onto, or both surjective and injective. The domain and codomain are of equal size. It also means there's one-to-one means the value in the range is used no more than once. And also onto meant that every element in the codomain maps to at least one element into the codomain. So notice there's nobody left behind, and there's a mapping for one-to-one from every item in the codomain to the domain, or vice versa really on this one. So notice the range is the same size as the codomain because there's nobody in the Bermuda Triangle of our codomain. In a bad one, you could still have nobody in the not in the range, but you could have a mapping of 5 suddenly goes to the same item in Y that's already being used. That would be a bad bijective. So notice it's very easy. To be honest with you, everybody's got a responsibility and everybody has a solution. That's your good bijective function. Here's our first example, and really kind of an exercise that we would have from a book. Here it is laying out everything that we are looking for, and it's being very, very explicit, telling us what's in the range, what's in the domain, what's in the range, what is mapped out. It is telling us everything. And frankly, doing the drawing kind of answered a lot of our questions, to be very, very honest. The drawing, I don't believe, was in the book. I did the drawing. So what it's going to ask here is it's asking first if it's a onto, and that we have a value in the range that is not used more than once. Well, that's not true. It's not onto because B has multiple items being used for it, so it's a no there. Onto, every element of the codomain maps to at least one element. That's also not true. A is completely unused on this. So in this particular function and setup of this function, both of those are going to be no for one-to-one and for onto. So it certainly can't be bijective if it's no for both of those. For example number 2, which I'm barely fitting into the screen here, we have a very different function where it's x squared. You've seen this before. You've seen the mapping. You've seen the blob system before. So it really isn't crazy. But again, notice drawing things out really helps out with this too. But if you had to do it the long way, we can do it that way too. So again, one-to-one means, so let me read the whole thing, is the function f of x squared from the set of integers to the set of integers either one-to-one or onto. Okay, so we're looking for basically, is going to be a set of integers that we can use maps to another distinct set of integers from there. Now, one-to-one meant, again, a value in the range is not used more than once. So for one-to-one, remember it's a value in the range that's not used more than once. Range that's not used more. I can tell you right now, just because we know x squared, that's not going to happen. Because I could use 2 and negative 2, put that into our f of x, and get the same response, which is going to be our 4. So it's definitely not a one-to-one. Now, the onto, we already talked about this, but notice I tried, this time I'm showing negatives. Notice there's some values in here that I just can't reach. I can't reach a negative value. I can't reach an odd value. So it's definitely not onto either, which means that every element in the codomain maps to, nope, there's some that are definitely going to be left out with this particular function. And notice how the drawing kind of helped us explain things too. Just heads up.